Okay, we're going to go ahead and get started. Kinesiology questions. So let's see. I think this is only going to record 30 minutes or so we're going to have to do this in two parts probably. Part one, going over kinesiology questions. Now, I hope I'm in the screen the right way. I haven't looked at this slideshow in the last couple of weeks since I created it, so be patient with me as we go over it. Well, that means we'll learn together. It's like we're in a study session. We're in class together and we're in a study session. And not only are we going to be learning from the questions or the answers, we're not only going to be learning from the answers, we're also going to be learning from the wrong answers. Let me just go through and talk to you about why I'm here, why I'm doing this. My name is Michelle Bullock. I'm a licensed massage therapist in the state of Washington. And several years ago, I took the MBLEx when I still had a month left of my massage therapy program. I also have an undergraduate degree in the medical sciences, and I have a very, very short memory, I guess, because it just falls right back out of my head immediately, and I had to learn it all over again. And the MBLEx was really challenging for me. Studying was a really hard thing for me because I'm a very active person, kind of like a hyperactive person. So I need to be working on some kind of like physical activity, doing something with my hands, or I can like where I can listen and like be doing something. I had a lot of work to do, yard work to do, property. I manage property here, and so I had a lot of work to do, and so it was hard for me to make time to study and do that. And so with all of those factors together, I was just way better off doing practice questions because that engaged me in a different way than just opening a book and reading through information and not remembering anything. So I did as many practice questions as I could. And I also listened to podcasts and listened to audio recordings of like YouTube's. Like I would just put YouTube on audio and just listen to it. So and there are a few other um, MBLEx YouTube channels out there. So keep an eye out for those. Those are the ones that I studied from. But I want to be part of this as well because I feel like I can share. And this is an interesting topic. So going forward in this webinar, we're going to talk about the topic of kinesiology and go over some questions in the MBLEx-style. So that's first the question, and then we'll have the four possible answers, A, B, C, D. We'll choose which one we think it's most likely to be the best answer. There might be several good answers, but the best answer, which is the way that MBLEx does things. As we're going through, we're going to learn how to pick apart the question when we're reading it and get all of the valuable information we need in order to answer the question the best we can. And we're going to eliminate the answers that it couldn't be. All right. So hopefully through this webinar, we'll both get a clearer idea of what is expected of us in the topic of kinesiology. And we'll learn a lot, and that's really great. So there are three sections to the MBLEx, the massage and bodywork licensing exam, as it was created by the Federation of State Massage Therapy Boards. So the first section would be your basic healthcare worker knowledge, anatomy and physiology, and then kinesiology. That's like the nuts and bolts of understanding how things work. And then the next section of that is going to be the manual practitioner concepts, which is the pathology and contraindications, the benefits and effects of soft tissue manipulation. I call that the massage therapy section. And then client assessment and reassessment. So those are all that's the majority of the exam is going to be those sections. Over 50% of your exam is going to be coming from those three sections. And the final two topics are about ethics and professional practice. That's like the business and the social etiquette aspects. But going back real quick, we are on the to me, it's the densest, most challenging stuff to memorize, but it accounts for the least when it comes to the exam. But you do need to know this stuff because it bleeds over into the other section going into pathology and soft tissue manipulation and client assessment, you're going to need to know kinesiology for that, even though it only accounts for like 12%. Okay, so content for kinesiology, we're going to need to know all the muscles. We're going to need to know the anatomy and physiology of the muscular system from the micro, which is like the cellular structure of a muscle, to the macro, which is how the muscles contract and relax. And you'll need to know, of course, contractions, muscle contractions. You have to understand how proprioceptors work. You'll need to know skeletal muscle locations, attachments, and actions. So what all the muscles, where they are, where they attach, and what they do. That's, to me, the thickest. That's the most. Even though it doesn't account for very much in the exam at all, that's what I do in my massage therapy practice, rather than like concern myself with the relaxation aspects. I am much more of a medical massage therapist. So to me, that's like the most important. That's my love right there. But it's a lot to memorize. Joint structure and function. So you'll need to know all the joints, and you'll need to know how they're structured and how they work. And then all your range of motion stuff. Okay, so I have this is like an outline of everything you'll need to know according to the Federation of State Massage Therapy Boards. This is everything that they'll want you to know, this stuff right here. Muscular system, concepts and muscle contractions, joint structure and function, and range of motion. They want you to know all of that stuff. But I have a study guide that's already ready to go that has all of this information for you. I'm not going to spend a whole bunch of time working on that right now. Going over that with you. If you go into the description of this video, it will take you to a link tree that will take you to a free study guide that I have created. It's a PDF that you can get printed up. You just put your email in and it will send that study guide to you. And so it's not just for kinesiology, it's for all the topics as outlined by the Federation of State Massage Therapy Boards. You're welcome. Okay, but without any further ado, we're going to go into the questions. So the first couple of questions are going to have to do with the muscular system, how it works from the micro to the macro. Okay, so here's the question. Which type of muscle fiber is most resistant to fatigue and specialized for endurance activity? So let's go over that question again and get the important information that's going to help us to understand which answer might be correct. So we've got type of muscle fiber. Okay, we have different types of muscle fibers. Is most resistant to fatigue and specialized for endurance. So which of these muscle types is for endurance, right? So we've got A, type 1, slow twitch. B, type 2A, fast twitch, intermediate. C, type 2B, fast twitch, glycolytic. Or type 2X, which is fast twitch and fatigable. So we're looking for a muscle fiber. All of these are muscle fibers. We've got type 1 and then 3 different type 2s. Basically, we got the 2 different types of muscle fibers, type 1 and type 2, which is really what you need to know. All the other information is kind of extra. But which is resistant to fatigue? We know that type 2X, fatigable, that's D, can't be right. Specialized for endurance. So do we think that fast twitch, any of those 3, B, C, and D, type 2 fast twitch, do we think that any of those would be resistant to fatigue or specialized for endurance? I don't think so. I think that the slow twitch is going to be better for endurance because it's not going to use up its energy as quickly. Are you all ready? I'm guessing A, type 1. Yay, I was right. A, type 1, slow twitch. Explanation. All right, this is the explanation I have on the slideshow. Type 1 muscle fibers are highly resistant to fatigue due to their abundant mitochondria, rich blood supply, and reliance on aerobic metabolism. They're ideal for endurance activities such as long distance running, whereas fast twitch fibers, type 2, are better suited for short bursts of power and speed. Okay. A second question for the muscular system. What is the basic contractile unit of a muscle fiber called? All right. Basic contractile unit of a muscle fiber. What part of the muscle fiber contracts? What is the smallest part of the muscle fiber that contracts? Here are our options. A is myofibril. B is sarcomere. C is actin. D is myosin. Okay, so two of those, C and D, actin and myosin, I think are not the contractile unit because they are the molecules that fire together to create the contraction. So I already know that those two can't be right. Check, check. Bum, bum. Getting rid of those. I put a line through them if I could. So it's either a myofibril or a sarcomere. A myofibril. So myo meaning regarding muscle, fibril meaning a fiber. And we're talking about a muscle fiber here. So I don't think it's myofibril just by picking the word apart, okay? Sarcomere, I think, has to be the answer by default. So let's go ahead and find out. B, sarcomere. Yay! The sarcomere is the basic contractile unit of a muscle fiber. It's composed of actin, thin filaments, and myosin, thick filaments, which slide past each other during muscle contraction. Myofibrils are muscles of sarcomeres within a muscle cell, while actin and myosin are components of the sarcomere structure. So they aren't the molecules that create the contraction. They are the actin and myosin are the components that slide past each other. I knew it had something to do with the contraction itself, but I wasn't sure if I knew it wasn't the unit either. So myofibrils are bundles of sarcomeres. Okay. Maybe we can find an image here of a sarcomere. Let's look that up. Ooh, too many M's. ERE. And we'll look up Google Images. Ooh, what is the structure of a skeletal muscle? That's a video. I don't want to do that. Ooh, look at this. This is one. This looks like one from my textbook. So a sarcomere is the section of the contractile area. Okay. So there's the thin filaments and the thick filaments. All right. So this must be actin and myosin right here, the red and the blue. They must be the parts that slide past each other. Do we have any other images? Look at this one. So we have myosin tail and actin filament. So the actin would be the outside one and the myosin is the inside one. And this whole bundle is called a sarcomere. And a bunch of them is called a myofilament. Look at this. Look how much we learned. Awesome. And I'm curious how I'm doing on my recording. I'm already 15 minutes through it. Hey Siri, please set a timer for 14 minutes. Okay, so let's get back to what I was doing. Okay, next. Muscular system, question number 3. What is the primary function of Golgi tendon organs in muscle tissue? So these are proprioceptors, aren't they? Okay, so Golgi tendon organs, primary function. What are Golgi tendon organs? They're proprioceptors, okay? Proprioceptors that help us to be able to sense stuff. So what does it sense? It detects changes. A, detects changes in muscle length. B, detects changes in muscle tension. C, initiates a muscle contraction. Or D, prevents muscle fatigue? Well, we know that GTOs don't prevent muscle fatigue because they're proprioceptors, right? So they don't prevent things. Do they initiate a muscle contraction? No, I don't think so. What initiates muscle contraction? That would be like a motor unit. Let's see, detects changes in muscle length or detects changes in muscle tension. I do believe that the other proprioceptor detects muscle length. I think that it's B, detects changes in muscle tension. Which one? Which proprioceptor was it called? I have to look back in my study guide here. Muscle spindles. Muscle spindles detect the changes in length. That's what it is. So where are we at? Slow twitch. Thank you for your patience with me while I'm sorting myself out here. Okay. So I think that it's muscle spindles that detect changes in length, and then the GTOs detect changes in tension. So let's see. Tension, yay, B. So GTOs are sensory receptors located in tendons that monitor and respond to changes in muscle tension. They help protect muscles and tendons from excessive force by triggering relaxation, which is inhibition, when tension becomes too high in the muscle. Muscle spindles, in contrast, detect changes in muscle length and contribute to stretch reflexes. So if you stretch your muscle too far, then the muscle spindles activate and force a relaxation. The Golgi tendon organs force inhibition of the muscle when there's too much tension in the muscle. That's why when you're trying to pick something up that's way too heavy, your GTOs will sense it and make you drop that really, really heavy thing. Okay, fourth question, the muscles. Which muscle is responsible for dorsiflexion of the foot at the ankle joint? All right, so dorsiflexion. Dorsiflexion. So plantar flexion is when you step down on the on the gas, and dorsiflexion is when you take your foot off the gas. That's the way I do it. Plantar is down, dorsi's up. Dorsi is the back side of the top side of your foot. Okay. So dorsiflexion means foot up at the ankle joint. All right. So that's the information that we need to know. So our options are A, gastrocnemius, B, soleus, C, tibialis anterior, or D, peroneus longus. So starting with gastrocnemius and soleus, which are two muscles that are in your calves. So I'm like going to show you my foot here. When the calf muscles contract, the foot goes down. So that would be plantar flexion, right? Foot goes down. So it can't be those first two. Tibialis anterior, it's the tibia muscle right here. It's in the front. So when it contracts, your foot goes up. Cool. Peroneus longus is the same thing as fibularis longus, which is on the side, which will cause eversion. Eversion. Sideways, right? So the answer's got to be C, because we just have to consider where each of these muscles are. Let's see. C, tibialis anterior. It's the primary muscle responsible for dorsiflexion, lifting the foot toward the shin. Gastrocnemius and soleus are involved in plantar flexion, while the peroneus longus aids in eversion and plantar flexion. So also it makes the foot go down. Okay. So where does the biceps brachii muscle originate? A, coracoid process and supraglenoid tubercle of the scapula. B, acromion and spine of the scapula. C, medial epicondyle of the humerus. Or D, lateral border of the scapula. So let's go through and remember where our biceps brachii hangs out. So we know the insertion is going to be toward the outside, right? And the origin is going to be toward the inside. So if the biceps is here and we like do a little curl curl our guns and we can feel kind of where that muscle is going, right? So we know it's going to be up here when we feel up here. And it's biceps, so it's going to have two origins, all right? Two heads, biceps, okay? So lateral border of the scapula can't be right because that's just one insertion, one origin, right? So D is out. C is medial epicondyle of the humerus. That's out because it's only one origin. So acromion and spine of the scapula are two options, right? Let's think about this. Where's the acromion of the scapula? It's right here, the acromion process, right? The acromial process is going to be right here on the side. And the spine of the scapula is back here along this line here. So biceps, we can feel it coming around the front. So that can't be right because it doesn't come up this far back, right? So coracoid process has got to be one of them. And that's the only, because it comes right up here to this place. You can feel it attached right here at the coracoid process of your shoulder. So that's got to be the right one. A has got to be the right one. Let me just like do right here. And supraglenoid tubercle of the scapula. Now, I don't remember that being, I thought the long head goes deep inside, but A, the biceps brachii has two origins. The short head originates from the coracoid process, and the long head originates from the supraglenoid tubercle of the scapula. These origins allow the muscle to assist in flexion of the elbow and shoulder. Let me look at my trail guide app here because I thought the long head goes into the shoulder socket. Trail guide. I'm on hips here. Let's see. Shoulder and arm, individual muscles, bicep brachii, and it says supraglenoid tubercle of the scapula. But it looks like it's deep inside of that socket. So it goes over the head of the humerus and goes deep inside. Sometimes I confuse that when people have pain in this area, I can like kind of confuse it with the supraspinatus, which also attaches in this area as well. So it's important to have people do a curl to find out if that's the right one, or lift their shoulder, lift their arm just a little bit, abduct their arm, and then it's like, oh, okay, that's where the pain is when you do that. That's how you can differentiate those two. Let's see. Well, I guess I'm just going to go ahead and close out this section. Now let's do one more. Okay. What is the insertion of the rectus femoris muscle? Where's your rectus femoris again? Femur. That means it's on your leg. So we know that the rectus femoris is one of the big old quad muscles. Insertion is going to be the one that's farther away, and the origin is the one that's going to be closer to the center. So A, iliotibial band, B, tibial tuberosity via the patellar ligament, C, greater trochanter of the femur, or D, medial epicondyle of the femur. So we have to remember what the quad muscles do. They help us to be able to straighten out our leg. They contract and our leg straightens up. So it creates extension of the leg at the knee. So in order for your knee to straighten out, for your leg to straighten out, or your leg to extend, that means that the insertion for the quad muscles can't be on the femur, or else the knee wouldn't bend, wouldn't straighten out. So it can't be the last two, either the trochanter of the femur or the medial epicondyle of the femur, period. Iliotibial band. Does the rectus femoris, the main quad muscle, attach to the IT band? That would be the answer A. Don't think so. No, it's not one of those. So that means by default, it's got to be B, the tibial tuberosity via the patellar ligament. Because we know that all the quad muscles Their big old tendon wraps over the top of the patella. B. The answer is B, tibial tuberosity via the patellar ligament. The rectus femoris, part of the quadriceps group, inserts into the tibial tuberosity through the patellar ligament. This insertion allows the muscle to extend the knee and assist with hip flexion. Okay, so back where we were, I'm just going to end up putting these two videos together. Hopefully everything's working on recording my face, talking, because that was the issue before. Okay, so moving on to the seventh question, which is based on concepts of muscle contraction. So what type of muscle contraction occurs when the muscle lengthens while under tension? So imagine that you're tensing up the muscle and you're also lengthening it. So like curl your bicep, right? And then while you're holding that muscle tight, you're also stretching it out. What is that muscle contraction called? Muscle lengthens while under tension. So here are our four choices. A is isometric. B is concentric. C, eccentric. And D, isokinetic. Okay, so our choices are A, isometric, B, concentric, C, eccentric, and D, isokinetic. So first of all, I don't think isokinetic is a thing. So we've got that, isokinetic, I'm going to check right off. Concentric, which is B, concentric muscle contraction, I believe is where you are just regularly contracting a muscle. Eccentric, I think that's the one where it's lengthening and tense at the same time. Whereas isometric, whenever I think of isometric, I think of the old Soviet exercises where they would have to just like stand there holding with their biceps flexed, holding a book. You have to just hold a book or a book in each arm. That's isometric. Whenever I remember an old boyfriend telling me about isometric exercises where you just had to hold a book. So I'm guessing C, eccentric. What have we got here? That's C, eccentric is the right answer. So an eccentric contraction occurs when the muscle lengthens while generating tension, such as when lowering a weight. So you're curling your bicep and you're uncurling your bicep, which is like the bicep's still contracted, but it's lengthening at the same time. Concentric contractions shorten the muscle, and isometric contractions maintain muscle length without movement. And isokinetic contraction, I'm going to have to hide this. Okay, isokinetic contractions involve constant speed with variable resistance. I'm going to have to look that up eventually. I don't think that's something we necessarily need to know for the MBLEx. All right, number 8, concepts of muscle contraction. During the muscle contraction, which structure slides over the other to shorten the sarcomere? Muscle contraction, structure slides over the other to make the sarcomere shorter. Okay, so we were just talking about sarcomeres, weren't we? And myosin and actin. So let's learn a little bit more right now. Muscle contraction, structure slides over the other to shorten the sarcomere. A, myosin slides over actin. B, actin slides over myosin. C, tropomyosin slides over troponin. And D, sarcolemma slides over the sarcomere. Okay, so shortening a sarcomere, we remember we were looking at the anatomy of a sarcomere, and we had actin and myosin, but I can't remember now which one was which, because like this, for you guys, the video is a lot shorter, but really for me, I've been sitting here trying to figure out how to edit this video for like 2 hours. So fell right out of my brain. So it's either going to be A or B. Tropomyosin slides over troponin. That's not a thing in regards to this question. So it's going to be actin sliding over the myosin or myosin sliding over the actin. Okay. You're going to make your guess, and I hope that you are right, either A or B. And it is B. Actin slides over the myosin. So myosin is in the center, Actin is over the outsides. In the sliding filament model, actin, the thin filaments, slides over myosin, the thick filaments, as the myosin heads attach to the binding sites on actin and pull them toward the center of the sarcomere. This shortens the sarcomere, leading to muscle contraction. I just want to see that image again, and of course, I have lost that original image that we were looking at because I was messing with sarcomere. I was messing with doing some editing. Sarcomere. Let's see. Come here. All right, so there's the image. Thin filament and thick filament. So the outside would be the the would be the actin. No, yeah, the actin is the thin filament, and the myosin is in the middle. So there you go. Okay. All right, back to where we were. What's the next question? Joint structure and function. Which type of joint is characterized by a fluid-filled cavity and allows a wide range of motion? So we are looking at joint types, okay? Fluid-filled cavity and allows a wide range of motion. We know we have 3 different joint types. We have fibrous, we have cartilaginous, and we have synovial joints. Pivot joint is a kind of synovial joint. So that D is going to be out, right? So A would be fibrous joint, B would be cartilaginous joint, C would be synovial joint, and D would be a pivot joint. So A we know can't be right because that's the kind of joint that doesn't move very much. For example, like the fusions in the pelvic girdle, right? The cartilaginous joint. What's an example of a cartilaginous joint? I'm going to look this up on my phone. Type of joint that connects bones using cartilage. Intervertebral discs, pubic symphysis, costovertebral joints, right? And then synovial joint, which is your classic joint, like in our elbows and our knees and in our like around our necks, right? So I'm going to say synovial joint. C. Synovial joints are the most movable joints in the body, featuring a fluid-filled cavity that reduces friction and facilitates movement. Examples include the shoulder, knee, and hip. Fibrous joints are immovable, and cartilaginous joints allow limited movement, and pivot joints are a specific type of synovial joint. Yay! Okay, joint structure and function again. What type of movement occurs at a hinge joint? A hinge joint is a type of synovial joint. So what is a hinge joint, right? We have a bunch of different kinds of joints, a bunch of different kinds of synovial joints. What does a hinge joint do? How many planes of movement does a hinge joint have? If you think of like a door hinge, it's going to be basically doing this, right? So it just has open and close. So flexion and extension is A, B is rotation, C is abduction and adduction, and D is circumduction. And I'm thinking C, abduction and adduction, are just planes of movement, not planes of movement, but actions at joints. It's not. It's not one of the classifications of movement for a joint. So we know rotation and circumduction are going to be like round and round, and that's not what a hinge joint is going to do. So I'm guessing A. This is how we answer these MBLEx questions. We're just going through each one instead of getting totally overwhelmed. We're going to go through each one and be like, which one's going to be the best answer? Which ones could it not be, for sure, right? So the answer is A, flexion and extension. Hinge joints, such as at the elbow and knee, allow movement in a single plane, permitting flexion, bending, and extension, which is straightening. Other movements like rotation or abduction occur in different types of synovial joints, such as pivot or ball and socket joints. All right, range of motion questions for kinesiology. When testing passive range of motion, what is the role of the client? A, the client actively moves the joint through its range of motion. B, the client resists the therapist's movements. C, the client remains relaxed while the therapist moves the joint. And D, the client contracts the muscles surrounding the joint. Okay, so let's go through the question again. Passive range of motion. What does the client do when you're testing passive range of motion on them? So does the client actively move? No. A is out. Passive means not. They're not moving, right? They're laying still. B, the client resists the therapist's movements. So A would be active range of motion, AROM. B would be resisted range of motion, RROM. C, the client remains relaxed while the therapist moves the joint. That sounds like the best answer. And then D, the client contracts the muscles surrounding the joint. So that's the same thing as active. So it's got to be C. Yep, the client remains relaxed while the therapist moves the joint. During PROM testing, passive range of motion testing, the therapist moves the client's joint through its range of motion while the client remains relaxed. This assessment evaluates the joint's flexibility and potential restrictions without the influence of muscle activity. Can we remember what passive range of motion is testing for? Passive range of motion is testing for whether it's even a muscle issue at all. If somebody's issues are muscle related at all, it could be that the issue is joint related or ligament related. In which case, when there would still be discomfort or some kind of sensation that's not pleasant, even with passive movement. But if it's a muscular thing, it typically takes engaging the muscle for that to be an issue. Okay. Number 12, another range of motion question. Which of the following actions involves the scapula moving upward along the thoracic cage? Okay. Action, scapula moving up along the thoracic cage. So A, protraction, B, retraction, C, elevation, or D, depression. So let's look through this again. Scapula's on our back. Scapula moves up. That means going up, right? Upward along the thoracic cage is your ribs, basically, your rib cage, right? Scapula's going up. So protraction is usually where the scapula is going out. Scapula goes out with protraction. Retraction, scapula comes in. Protraction, retraction, okay? Elevation is where the scapula goes up, and depression is where the scapula goes down. So it can't be depression, it can't be retraction, it can't be protraction, it's got to be elevation. Let's give that a try. C, elevation. Yeah! Scapular elevation involves the scapula moving upward along the thoracic cage, as seen when shrugging the shoulders. Protraction moves the scapula forward, retraction pulls it back, and depression moves it downward. Okay. All right, well, that's it. Those are all of our questions. That wasn't even such a big deal. 12 kinesiology questions. So now you know more about the kinds of questions that are going to be asked on the MBLEx, and we had a little bit of practice remembering specific things that we need to know about kinesiology. So in the description of this video, you can find links to some free resources, absolutely free for you. There's a free study guide outlining exactly what you need to know for the MBLEx exam. I got that information from the Federation of State Massage Therapy Boards, and it's all 7 categories, all 7 topics is laid out, and exactly what you need to know is listed underneath them. And also another free resource is a 100 question practice test. It's in PDF form, so all you have to do is print it up, and then you set this a timer for 110 minutes. You take the test, and then the answers follow that. You have a bunch of answers, and then you can find out not only will you find out what the correct answers are for each of those questions, you find out just like what we did with this, we're learning more about the topics according to what the answers aren't, right? We're like, wow, what is that? We look it up, right? And then also, like, there's an explanation for each of the questions, and then there's an answer key at at the very end for the topics for each question. So you can go through and circle in the key under each topic, the number of the questions are listed. Circle the numbers, and you will see which ones you missed. Let me see. Let me just show you real quick. We got time, right? Let's see. Where are my projects? Why are you taking so long, Canva? Oh, here's some MBLEx tests. Okay. This is where I format my tests. My computer's being kind of slow because it's doing a lot of stuff. Come over here to the answer key. Okay. There's the answer key. No, that's not it. That's the end of the test. Come over here to the answer key. There it is. All right. So I'm expanding that, coming down. There's the answer key. So all these questions are in the topic of kinesiology. You missed number 85 in kinesiology, you circle it. So you can see which topics you need more practice on according to how many you missed. If you missed a whole bunch in benefits and effects of soft tissue manipulation, then you know that you need to spend some more time studying on that. All right. So with that, we're going to go ahead and finish up. And I'm so grateful for you guys for being here today. And I will see you in future videos. Make sure and subscribe. Come on now. Make sure and subscribe, and I will see you all on the flip side. Bye.